Have you ever wondered why a rainbow forms after a rainstorm? Or how the smell of fresh coffee spreads across the room before you even take a sip? Energy and matter are always moving. They spread and transform in different ways. Two key processes describe how things spread: dispersion and diffusion. At first, they might seem similar, but they work differently and apply to different physical phenomena. What is dispersion? Dispersion happens when waves, such as light, sound, or water waves, spread out over time. It occurs through the propagation of a wave when it has more than one frequency. This happens because different parts of a wave move at different speeds. This causes the wave to change shape as it travels. Take light passing through a prism. Suddenly, a single beam transforms into a beautiful spread of colors, each bending at its own angle. White light splits into a rainbow because different colors travel at different speeds through the glass, causing it to bend at a unique angle. This variation in speed is usually linked to the light's frequency. Other examples include water waves spreading as they move, sound waves changing as they travel through different materials. But dispersion isn't the only way things spread. So what is diffusion? Diffusion refers to the process by which particles move from areas of high concentration to low, gradually spreading out. Unlike dispersion, diffusion does not depend on frequency. Instead, it's driven by random motion. Think of perfume spreading in a room. The scent molecules move randomly until they fill the space. Milk mixing in water. When you drop milk into water, the milk particles move randomly and spread throughout the water until they are fully mixed. Oxygen in your lungs. It moves from high concentration in the lungs into your bloodstream. With these two processes in mind, this leaves us with one key question: how are they different? Dispersion affects waves. Diffusion affects particles. Dispersion depends on frequency. Diffusion happens randomly. Dispersion changes wave shape. Diffusion spreads substances evenly. Why does this matter? One of the most powerful aspects of science is our ability to describe natural processes with equations. By deriving equations that describe the processes of dispersion and diffusion, we can predict how these phenomena behave in different scenarios and solve real-world problems. For dispersion, we use equations like the dispersion relation, which helps us understand how waves of different frequencies travel at different speeds. This is crucial for predicting how light behaves when it passes through various materials, such as glass or water. Dispersion plays a key role in technologies like fiber optics, where understanding how different wavelengths of light travel is essential for communication systems. Similarly, diffusion is another process that can be described with equations. For example, Fick's law of diffusion. This equation describes how particles spread out due to random motion, helping us predict how their movement will evolve over time, from the movement of gases in the atmosphere to the way oxygen diffuses from our lungs into the bloodstream. By using these laws, we can predict how substances will mix and spread over time, which has applications in medicine, environmental science, and chemistry. For example, they help us model how heat moves through materials or how pollutants spread in the environment. Conclusion. While dispersion and diffusion both describe how things spread, they are fundamentally different. Dispersion affects waves and is driven by differences in frequencies. Diffusion affects particles and is driven by the random motion of molecules. So, whether it's light splitting into a rainbow or particles spreading through a room, both dispersion and diffusion are fundamental processes that shape the world around us. Understanding these concepts and the equations that describe them allows us to make predictions and solve real-world problems, from predicting weather patterns to understanding biological processes. Both phenomena help us see and understand the intricate dance of energy and matter in our universe. So, next time you see a rainbow or smell fresh coffee, you'll know why. Thanks for watching. Like, subscribe, and explore more science with us.